I want to just briefly tell you a little bit about atoms versus ions as we start looking at particles and getting into calculating average atomic mass a little bit later. We need to also consider that protons and electrons so far have been considered to be equal. 6 protons in a carbon atom, 6 electrons in that carbon atom. Makes it neutral, makes it balanced. Okay? And in any atom where that's the case, we would consider it a neutral atom. An atom is neutral to start out with. In other words, the number of protons is equal to the number of electrons. Those two cancel each other out. Positive cancels out negative, and it's sort of balanced. Think about it like a balanced budget. Your income versus your expenditure. If those are exactly the same, then you're evenly balanced. The fight in Washington always to balance the budget and at least come out even. Very difficult thing to do. But in the atom, protons and electrons, to stay nice and balanced, means to have a neutral atom. In the end, we often work with ions. If an atom gains or loses electrons, it'll no longer be neutral. If the proton number and the electron number are not equal, you have an ion, which is, we would say, charged. In other words, it's not balanced out. The atoms that we'll work with in chemistry can either gain electrons. If you gain electrons, you now have more electrons than you do protons. And so if you start out neutral with the number of protons and the number of electrons, if you gain electrons, you'll now have extra negative charge, and you'll be negatively charged overall. 1 for each electron that you've gained. The other alternative is you can lose electrons. So if you start out with equal protons and electrons, and you now lose electrons, you'll now have extra protons compared to your electrons, and you'll now be positively charged, 1 for every electron that you've lost. It's really important to remember and note at this point, and we'll get more into this later, that protons and neutrons are not lost and gained in these typical ways that we're talking about here. And so if you're going to become charged, either positive or negative, it's not because the protons are changing, because they don't just come and go. Electrons are kind of the free currency of atoms. They can be spent, they can be gained, and electrons kind of come and go pretty easily among atoms, and that gives atoms charges. If protons and electrons start equally and electrons are gained, you become negative. If protons and electrons start equally and you lose electrons, you're now positive because your positive side is higher. Notice my proton hand here on this side is not changing, but electrons can be gained or lost, and the balance between protons and electrons changes as a result. Really important idea. As we look at an overall symbol, then you'll see this abbreviation, and we'll conclude with this for now. Notice in the middle you have a PD. You can look that up on your periodic table. That's the element palladium. In the bottom left, you can see its atomic number is 46. That means it has 46 protons, and you can confirm that on your periodic table. In the upper left, you see that this particular palladium atom has a mass of 108, or 108 atomic mass units. So that's the number you'll see in the upper left corner when we abbreviate it in this form. And in the upper right corner, you see the charge. And you'll notice here I mentioned that it's shown for ions only. In this case, palladium has an overall charge of 2+. Now remember, to become positive, you have to lose 2 electrons. In this case, to get to be 2+, you have to lose 2 electrons. In order to become positive, you lose electrons in general. And so in this case, this is a palladium that has lost 2 electrons and now has 2 extra protons compared to the electrons that it has. And so this is just sort of a layout that you'll see as we practice these symbols. The abbreviation surrounded by up to 3 different values. In the bottom left, the atomic number. In the upper left, the atomic mass. And in the upper right, the charge, if it's an ion. One additional example, here's an element Sb, which you'll find on your periodic table. It is called antimony. In the bottom left corner, the atomic number is 51, meaning that it has 51 protons. In the upper left corner, the atomic mass is 123 AMUs, which is the total of protons and neutrons for antimony. And in the upper right would be its charge. Now you'll notice, because there's nothing shown here, we can assume that this is an antimony that is neutral and has a charge of 0. We don't show that 0 typically. It's left off and assumed if it's not shown. So in this case, we're working with a neutral atom of antimony. That's it for atomic number, atomic mass, and introducing you to these symbols. We'll come back with calculating and practicing on some of these symbols in a little bit. They're an important way of condensely, that's not a word. Sorry about that. They're a way of very compact way of showing lots of information about an atom in just a snap. And we can show that here in this. We'll be back with that practice in the next video. So the next thing we're going to practice, finally I guess practicing something with subatomic particles, is a sheet called mapping the atom. Now that's a very unofficial term for it. I just kind of think it got assigned to it a while back and it's just never changed from my class. So no particular skill called mapping, but we're going to look at sort of just relationships between protons, neutrons, electrons, atomic number, atomic mass, charge or being neutral as an atom or ion, and the symbols that we use to kind of summarize all that together for an element. So you should have, hopefully, a page that looks something like this one from me in class. If you're watching this video way in advance, getting ahead for some reason, great. Then the worksheet is on Moodle, and you can download it. I believe it's called Mapping the Atom Practice 1 or something like that. And so you can download that page and print it if you were eager to get started on it, or you can fill it in on a blank sheet of paper or something to look like this too. But you should have one from me in class by the time this video is assigned or is getting close to being assigned. So this page has several rows of elements on it with some information given and other information not. I'm just going to go through the first several or variety of examples on here with you, have you fill in a few of these with me, and then as we're going, you can hopefully get enough background on examples so you can do some of these for yourself. So you'll find on each row that you're given some of the blanks, at least one, and then you're asked to basically fill in all the rest. There's one key assumption that I want you to make on this page, and anytime we're working with this, that unless you have information that says otherwise, you can assume you're always working with a neutral atom. Now that doesn't always mean that it's going to be neutral, of course, because there could be information there that should tell you, or you should be able to turn that information into the truth that in fact we're working with an ion. So be really careful about assuming that it's an atom, but if you can't find anything there that tells you otherwise, you can assume that it's a neutral atom. That's true on this page, and there's another one that's kind of like it that I may give you to practice on. You can always assume they're neutral unless something says otherwise. So we're going to get going on this page and practice a little bit on some of the blanks that are here to fill in. If you don't mind, I'm going to change my pen color real quick before I forget to, because I don't like red. It doesn't show up as nicely, and I like the blue better. So on this page, you've got number 1 here, palladium. This is an example from the video that I showed you on these symbols. And so you can go to the periodic table and look it up, but just to kind of take you through the process, I'm going to show you on a periodic table that I'll have on the screen for you how I would get started. So I'm looking at number 1, I'm seeing here that it's got PD for a symbol. And in the bottom left, you'll recall that bottom left number is atomic number. So we should be able to just come right on here and say, okay, well, PD's atomic number then is 46, even if I don't know that PD is palladium. Let's take a moment though and go to the periodic table and find it. So I'll switch over here to my periodic table, and you'll find that palladium is right there, kind of in the middle of the screen, number 46. So you could find this element on your periodic table by either looking for the 46 atomic number, or if you didn't know that was atomic number, then you could go to the periodic table and look for PD. In any case, here it is, right in the middle of our screen. So sure enough, it's palladium, P-A-L-L-A-D-I-U-M. So watch those spellings, and we'll go ahead and fill those in here. On the first row, palladium, P-A-L-L-A-D-I-U-M. And sometimes I'll tell you some stories about the names and where they come from and what they mean. I won't on this one, but there are some interesting stories on almost all of them. So if you're ever curious, you can look online a number of places, sometimes just as simple as going to Wikipedia, and it'll tell you some of the history behind the names of the elements. So that was kind of cool. Atomic mass is our next column, and you don't have to necessarily go in order. Sometimes you can jump around. So for example, maybe you know that atomic mass is the top left number on this symbol. So this 108 here in the upper left corner gives us the atomic mass of 108. Even better might be to say 108 AMUs, right? Because that's the unit. So 108 AMUs, if you want to squeeze that in there. In other words, all the atomic masses on this page will be in AMUs. So maybe we can just write it at the top of our page and then know that from now on everything in that column is AMUs as well. Is this an atom or an ion? Well, remember, an atom means it's neutral, and an ion means it has a charge, positive or negative. Well, we can see right here in this example that it's big old 2+ in the upper right-hand corner. So that's an ion, that's a charge. It's got a charge, it's an ion. Specifically, its charge is given there as 2+, 2 positive. Now, what does that mean? I'll think about that here in just a second. Well, let's fill in what we know out of the 3 remaining boxes. Remember that atomic number in your notes was defined as the number of protons in an atom. That's a basic fact. That's what atomic number is. So atomic number 46 means that we have to have 46 protons. Those 2 columns will always be the same. Atomic number and protons will always be equal, always, always, always. take that when you can get it. There aren't very many absolutes. Neutrons, our next column over here, don't forget neutrons are part of that mass, right? Neutrons are the second part of the atomic mass. Protons plus neutrons gives me atomic mass. So in this case, atomic mass is 108. That's given to me from the symbol in the upper left-hand corner. If I know I have 46 protons, then 46 protons plus some number of neutrons has to give me 108 AMUs for a total mass. So what's that total number of neutrons? Well, you take the mass, 108, and subtract the protons, which we know to be 46, and you should get an answer of 62. So there are 62 neutrons in this particular atom of palladium 108. 46 plus 62 gives me that 108. Now what about electrons? This is going to be the tricky one. And sometimes it goes counter to our sort of natural instinct to think that because it has a 2 plus, that I'm going to have extra electrons, when in fact that's not the case. Remember, positive protons and negative electrons, when they're equal, will give me a charge of 0. So if protons and electrons are equal, I have a charge of 0. Now how can I get a positive charge? That means the proton side is higher, right? And so in order to get more protons than electrons, I have to lose 1, 2 electrons. And so each electron that I lose gives me a positive charge. In this case, I've lost 2 electrons to get the positive 2 charge. And so how many electrons would be left? Well, if I've lost 2, I started out with the same number of protons and electrons. So if I lost 2 electrons, I would have just 44 left. So I have 44 electrons remaining. Think about it as then 46 positive charges plus or across from 44 negative charges gives you 2 extra positives. And those 2 positives then, the 2 protons that are in excess, give us the total positive 2 charge that you see here. Now I should note whether you write it as 2 plus or plus 2 makes no difference to me at all. You can write it as 2 plus or plus 2, and to me it's just as correct. You may bump into someone down the road who wants you to be very specific about that. For me, I don't care. In fact, I typically write 2 plus and say plus 2 when I'm saying it out loud. I'm not sure why I flip around like that, but a good example of how they're really pretty interchangeable. Let's look at another example.